Okay, so this is a short video just to try to give a little bit more clarity and guidance involving parallel lines in our triangles and in our proofs, and kind of like what becomes congruent from that, what angles become congruent, what we learn from these parallel lines. And so first I'm going to go over two just general examples. Example one is kind of this setup right here. And you can see I've marked the parallel symbol in the top and in the bottom, right? Parallel symbol, parallel symbol. And then we have an example two, kind of looks like a parallelogram kind of shape. So we have a parallel symbol and a parallel symbol. So let's kind of talk about what happens in each of those. And short answer to your question about if the lines in the triangles are parallel, does that mean all of the angles are congruent? No, it does not. Only very specific angles become congruent. And so let me draw some highlights, add some color, and we'll talk about that. So I'm going to highlight the parallel sides in blue. So obviously the parallel sides are important here. But then in each one of these diagrams, we're going to have a center line that goes through both of the parallel lines. So for instance, there's actually two of them in example one, but this pink one, that's what we're talking about. Now, we call that line a transversal. It's not too important that you know that, but we call that a transversal. So in this situation, we have blue parallel lines and a pink transversal that intersects both of them. So the only angles that are going to be congruent to each other are the ones where those parallel lines and that transversal intersect each other. And so that's going to be where the blue and the pink meet. So where I just drew this angle or this arrow right here, the pink arrow, that is one of those places, right? That is where a blue line and our pink line meet. And so we would be able to put like a little angle loop through there because we know that that's going to be congruent to another angle. Now, what angle is it going to be congruent to? Well, it's congruent to the other place in this diagram where the pink and the blue lines meet. And that's kind of down in this opposite corner. And so we'll add another congruent marking. And so those two are the congruent angles. And remember, we call them alternate interior angles. And so that's just basically how it works. And that's basically how it works in every single example. Parallel lines don't just make all angles congruent, they make the alternate interior angles congruent. And the alternate interior angles, again, are where our two colored lines here are intersecting. So in the two places that the blue and the pink lines meet each other, those would be congruent. And again, they are called, oops, I didn't mean to erase that, they're called alternate interior angles. Now, there are actually two lines in this diagram that are considered transversals. The pink one was one I drew, and now I'll draw in an orange one here. And it's, you know, the reverse, the opposite one of the pink one. And so that's a transversal as well. And so the two angles or the two corners where orange and blue meet, so orange transversal and then of course the blue parallel lines, those two corners will also be equal. Now they will be different than the pink ones. And so we can't just put one loop. I'll put a double loop here. So I'll put double orange loops. So yeah, they're different than the pink ones, but they are equal to each other. And again, it's just because that's where that middle transversal line and our parallel lines meet each other. And so those are going to be the angles that are congruent. And again, it's going to be called alternate interior angles. And so basically your goal in all of these problems that involve parallel lines is recognize which lines are parallel, recognize which line goes through both of them, and then where that parallel line meets and where that middle line meet, that angle will be congruent to the other place in the diagram where that's happening. And so let's kind of see how that shows up in example two. We'll highlight the parallel lines in blue again, blue and blue. And then we have a center line. So I'll highlight that. And then the two places where the blue and the pink are meeting, that will be in that corner and then down here in the opposite corner. Those are the two that are congruent. So I can put a little angle loop there and an angle loop down on this one as well. But in this diagram, that is the only place that's occurring. Nowhere else, there's not another center line. So nowhere else is there an intersection between our parallel lines and our center line. Only in these two spots, and so those are the only angles that we can say are congruent because of alternate interior angles in this diagram. And so what I would encourage you to do, and I'll try to show you both at the same time here, is just use color, right? Make your parallel lines a specific color, and then look for that center line that goes through them both, and where your parallel lines and that center line meet, those angles will be congruent, all right? Now, you also asked another question about problem 3, so let's get to problem 3. And your question was, there's a line that bisects a triangle to create 4 angles, 2 on the right side and 2 on the left. Are those congruent? And so that's a great question, and it comes from this piece of given information. It comes from this piece of given information. Because this piece of given information is the one, of course, that uses the word bisect, right? And so that's going to be the one that is creating 2 equal angles. And so let's see what's happening here. It says line SR bisects angle, this is our angle symbol, angle TSQ. So first, let's figure out what is angle TSQ. So let's follow the letters, starting at T, going to S, going to Q. It's like this whole angle. It's like the entire angle S, not just the little chunk on top, not just the little chunk on bottom, but the whole thing put together. It is the entire angle S. That's what TSQ means. That's why the S is in the middle of TSQ. And then if you just follow, the T to the S to the Q, you see that it's the entire shape, not just one of the little angles. But then it says line SR bisects that. So let's highlight SR. So from S to R, that's what it's doing. And so it bisect, remember, means cut in half. And so let's write that down real quick. Cut in half. And so essentially in this problem, what it's telling us is our red line is cutting our big blue angle in half. Now, when you cut something in half, it creates 2 equal but smaller halves, right? Or 2 equal but smaller chunks. And so the red line is cutting our big angle in half, and it is creating 2 equal but smaller halves of that angle. So what are those halves is going to be the question. And those halves come into play where our red line meets our blue angle. And so on the top side of that red line, we can put like a little arc loop. And then on the bottom, we would put one as well. Because in both of those angles, that is where our red line is meeting our blue angle, right? And so it's cutting that blue angle in half. So the top side of the red line has to be equal to the bottom side of the red line. Now, your question dealt with, it creates 4 angles, right? Because there are angles over here, top side of R and bottom side of R. But it doesn't say anything about bisecting R. It only talked about bisecting S. So we can only say that where we drew the pink angle loops here, we can only say that those are congruent. We can't do anything where I've drawn my orange arrows, because even though it looks like it, nowhere in this proof does it tell us that our red line does anything to angle R, or we could call it, TRQ. But it just doesn't say anything about that, and so we can't assume it, and so there's nothing else we can do. All we can do is say that the top side of S and the bottom side of S are equal, because that's the angle that we were told that got bisected, okay? And so just those 2 angles on the left, just the pink ones. Okay, I hope this was a valuable video for you. Let me know if that answered your questions. Let me know if you have any more. And thank you for your hard work. Keep it up.